work on the renovations around the courthouse had already begun, and they were well underway sometime in 2010, as I recall. But it didn't appear that there was any plan to get the clock working. Well, that was going to be strange, to say the least, to spend all this money on greenery and sprucing up the courthouse, and the clock was broken. So I decided I would just take that on as a project to try to get the clock going. And I was in contact with Darrell Butler, and he introduced me around. We went to Mayor Hill to talk to him, make sure it was all right, get his okay on the project. And Mayor Hill said that the county had the clock repaired sometime in fairly recent years, said they spent about $10,000 on it. The clock ran about 6 months and quit again. So I don't think he was very enthusiastic about going that route again. But he encouraged us to work on the clock when we were willing to do it. And I didn't know it at the time, but back in 2007, well, 3 years before we were talking to Mayor Hill, there's a group that proposed fixing the clock, and they recognized that there was a lot of deteriorated structure in the courthouse dome that needed to be replaced, and they were going to have the old wood taken out. They were going to have, as I recall, aluminum structure put in. It had to be designed. Well, it was going to be pretty expensive, and I don't think the county was going to fund them. For whatever reason, when I first saw the dome in there, it was 3 years after this project had been discussed, and it had evidently been abandoned because there wasn't anything going on. What we found in the dome, and I mentioned there actually sounded like there were 2 projects proposed. One was just getting clocks going. The other was to take the original clock mechanism, which was a Seth Thomas pendulum mechanism, and renovate it and put it in a museum or do something with it. They didn't appear to be proposing that they actually make that clock work, operate the clock face itself. But what we found up in the dome was not the original Seth Thomas clockwork. Instead, there was a later installation equipment from the IT Bergen company, which has been in the tower clock business for well over 100 years. The clock faces were electrically driven and were controlled by a panel in the county recorder's office. Okay, this is what was in Danny Falk's office. It's still there, in fact. This is a timer, sort of like the timer you turn on your Christmas tree lights or something like that. That basically controlled the bell, and it had little pegs that you could insert around it to determine when the bell would strike, and it had a couple of switches. You can't really read it on here. There was the hour strike, three bells for 3 o'clock and so on, and then there was a 30-minute strike of a single bell, and they had switches there that would enable that or disable it. This is a pilot clock. And then they had switches over here to turn that clock on and to operate the 4 clock faces of the dome. Let's see the next picture up here. It's a little closer look at the bell timer. Okay, up in the dome, on a platform that's about 22 feet off of the floor up in the dome, there was this gearbox. This was centrally located at the dome, about precisely in the middle. It had an electric motor on it and 4 shafts that came out, 4 different directions, one for each clock face. Each one of these had an extension shaft about 15 feet long on it, and that went out to an individual gearbox on the back of each clock face. The little motor was controlled from the switch panel downstairs, and when it was just in normal mode, it caused these shafts to rotate at 1 RPM. Shaft was, of course, hooked into the gearbox on the clock face. The gearbox on the back of each clock face would gear that down to 1 revolution per hour, which was the minute hand. And then it had another reduction in there, 12 to 1, to operate the hour hand. Yes?
All your mechanism looks like brass, is that correct?
There was some brass in it. I think the gears were steel, as I recall. The thing's still in my basement, if anybody wants it. It's a greasy mess. It had an oil sump in it, and it basically ran in oil. And I've had people tell me, well, the motor was a sewing machine motor. It sort of looked like it, but it's definitely not a sewing machine motor. In the first place, it has to be a synchronous motor to keep accurate time. And it had 2 internal gear reductions in it before it ever got to this shaft. And these other gears were set up so that in normal mode, these ends ran at 1 RPM. But if you reverse the motor, and there was a reverse switch downstairs, these shafts would run 30 RPM, run 30 times normal speed backwards. And that was the way you could quickly move the clock hands around to set the time. I remember as a kid seeing those clock hands move backwards. You could just, they were moving fast enough you could watch them move. So I guess this was in place back when I was growing up here at some point. I couldn't tell exactly when this thing was built, but it looked like something from the 50s or 60s, maybe as late as the 60s. Well, at any rate, a woman saw that and said, well, it just needs to be cleaned up. There had been some work done on flexible couplings that looked like this, but then these are something different. I think maybe they were trying to renovate it using a flexible coupling like you'd use to hook the motor onto a water pump or something. Well, at any rate, we took the thing out, Daryl and I took it home, and I got the motor to run all right. It didn't move, it didn't run for very long before it just froze up. And ended up taking the motor apart, and what was inside was insulation that was flaky. It had evidently been overheated on numerous occasions, and the insulation would just flake, and it would jam the rotor, and it would quit. And I'm supposing that's what had caused it to fail after the last fix had been done. Well, I had to have a plan B. I decided there's no way I could fix that motor. Didn't know where to get another one. Another tale circulating around the courthouse was that the last time they changed that motor, it cost $1,000. So in my work, I'd often use stepper motors for things. So I decided, well, I will try to fix the clock with stepper motors. And I found online these little motors. I found them for $18 a piece, and I bought enough of them for the clock and some spares. And then we proceeded to try to adapt the gearboxes that were on the back of the clock face to this little stepper motor. Incidentally, the side benefit to that is without, or if you put a stepper motor on each clock face, you don't need the central gearbox or anything. You don't need a 22-foot high structure in the middle of the dome to hold this thing, and you don't need shafts out each direction. And if you do it right, everything can be controlled from the floor. So it started out this is one of the shafts. The gearbox set up on the structure here, and this shaft ran out to the back of the clock. You can't see the little individual gearbox back there. And it was long enough, it had to have a support in the middle to hold it up. But this center of the clock face It's 22 feet off the floor. The floor's down there somewhere. The concrete of the dome comes down about this level, and then I think it's about, I believe it's 18 feet of brickwork down to the floor in the dome. Okay, from the outside, this is the south face of the clock. It doesn't show up here on this monitor, but the clock face was cracked all the way across on the south. If you look at it on the inside, this is what the south face looked like. Of course, the central disc on those clock faces is glass, and it's 33 inches across. And this is the south face. It's cracked all the way across with 2 large pieces and 2 small pieces that can be reclaimed. And this is just the shadow of the hands that you see inside the dome. Now, also, you notice it's got a sort of a pinkish tint. The glass that's up there is made in an old process that was, well, it was completely replaced, I think, in the 50s or even early 60s. They now make smooth plate glass by taking molten glass and floating it on a molten tin and let it harden. Back in the days when this was made, molten glass went out on rollers. And if you wanted nice plate glass, I think you had to grind it smooth on one side. There are little ridges all over the back of this glass where it ran over rollers, and the other side is round smooth. But it's got this pinkish tint. The pinkish tint comes from the fact that they used manganese in the to clarify glass back in around 1900 thereabouts. And manganese in the glass over years and years of exposure to sunlight produces that sort of pinkish tinge. Well, the easy thing to have done with this clock face would probably be just go down to Dyersburg Glass and get a piece of plexiglass cut to replace it, just this white plexiglass. But I thought, well, that's going to look different if we do that, so probably it'd be best to try to reuse the glass. So that's what happened. And let's see, Bob Dean, I think, helped with some of the work just to get that glass out there. The first thing they had to do to get the glass out, there's a number of bolts that bolt the glass into the numbers. The numbers are cast iron and comprise a frame to hold the glass. There are little panes of glass all the way around, but this central disc, which is 33 inches across, is the main thing. And then there's a hole through that glass, and that glass had to support the gearbox. The glass is a 1/4 inch thick. It's not terribly heavy, but it's a little unwieldy, and it's particularly unwieldy if it's got a big crack across it. But Darrell and I went down to the fire department before we started working on that and got safety harnesses and brought a big ladder up into the dome, and it took a couple hours of work on cutting these bolts to get them out. They were all rusty, and had to get an oscillating saw and cut on those things until finally got all the bolts loose. And then at that point you just get the glass out and the gearbox and the hands and everything and get them down where you could work on them. I got the broken glass, the gearbox, and the clock hands, got those down December 10th of 2010. So that was about the start of the real work on the clock. And I had a piece of plywood, cut out a circular piece of plywood, stick in there so maybe the pigeons wouldn't take up residence in the dome while we worked on the thing. Now let's show you some of the work I did on the glass. There's a close-up of one of the cracks. Been broken a while, you can tell because it built up rust in the crack. Okay. I took the glass in the hands and the gearbox and everything home, and fiberglass the broken disc. This fiberglass cloth added there, and then the thing was still not strong enough for fiberglass on it to handle it by itself, so made a wooden cradle and a clamp arrangement to hold the glass together while we handled it, and a hook to hoist it with. And I think Bob and Johnny Smith helped hoist this back up into the slot in the south clock face and put it back in. But of course we had to work on the gearboxes some too. Each clock face had its own individual gearbox. It looked like this. The shaft that came in from the central gearbox hooked on the inside, and then it had a nut and a bushing that fit through the hole in the glass disc. And then the hour hand went on this shaft and the minute hand on that shaft outside. And there was a right angle gear drive in here that drove a worm and a worm gear that drove the minute hand, and you had, like I said, a 12-to-1 reduction off that shaft to drive the hour hand. Let's see. I tried hooking on the stepper motor just to drive this shaft. That didn't work too well. So then modified the gearbox. Took out the shaft that normally came in from the central gearbox and put in a longer shaft here for this worm. Left this gear in place just as a clamp to hold things in place. But there's a gear gone from here and this shaft is gone. And with this extension you can drive the gearbox from a motor off to the side rather than being way behind it in the middle of the dome. It's just a foot or so off to one side. Incidentally, the gearboxes were designed to have oil in them. There was a label on them that said 2 ounce. I guess it's supposed to have 2 ounces of oil in there. The south gearbox didn't want to hold oil. They had to do some epoxy in it to get it so it would hold oil. A local machine shop gave me some stainless rod that was the right diameter for the worm. It had to be ground down a little bit at the end to fit in the bushing where it went. But it wasn't terribly difficult to change this mechanism to have this shaft extending out to the side. Okay, when we got the thing together, had to check it out. Well, here's one of the little stepper motors. Here's the extension. The extension is just 1/4-inch wooden dowling, incidentally. Doesn't take much torque to move the thing. And they're just rubber hose couplings between the motor and the wooden dowel, and between the wooden dowel and the gearbox, which is sort of hidden by the minute hand here. This is a minute hand. So put the thing together in the basement and set it operating. Incidentally, this is a laptop computer that is used to program a microprocessor. The control of the clock now is programmed into a microprocessor system. So I had to satisfy myself that indeed this thing would turn the hand accurately. And when it did, then we installed it in the courthouse.
Hey, John?
Yes.
Talk to him about the balance of that hand.
Oh, there's a counterweight. It would be difficult for the stepper motor to rotate this thing to get it from 6 o'clock up to 9 o'clock if you didn't have a counterweight on the end. The hour hand, the minute hand are both counterweighted. It's most important on the minute hand because there's additional gear reduction to the hour hand, and it'd work whether it's counterweighted or not. Yes.
The counterweight's same weight as the hand itself, or just a little over?
Well, the technical term is the moment. The center of gravity of it is designed to be right at the shaft, pivot point. This is the body of the hands is aluminum, but this is steel. So it's got a couple of rivets holding the hand that you see to this steel support, or whatever we'll call it behind. And then this is built up. You can't see this thicker down here, but there's a mass of iron down here that counterweights it. Okay, this was the installation on the south face of the courthouse. These white pieces here are some plastic material that used to sort of brace the glass disc and support the stepper motor. And once this was put in place, it went around it with this black silicone caulk. So the glass is in there pretty well right now. It wouldn't come out even if you took the clamps loose without cutting the silicone loose. It's in there pretty securely. And even though it's cracked, and I don't know whether long-term that fiberglass is going to stay on there well or not. I don't think it's ever going to come out unless somebody intentionally takes it out. Okay. Now, down at floor level in the dome, this box here was put in with IT burden equipment. It's got some relays in it. The main thing it did was strike the bell. It had a relay that clicks. Every time the relay clicks, a big solenoid whacks the bell. It's got a 240 volt driver over, or breaker over here, power the thing. The bell has to have a fairly high voltage to operate it. We'll get to that in a few minutes. The little motor's 110 volts. The bell actually takes 240. And this looks bad, this junction box with all these dangling wires. This junction box did have wiring that went up to the gearbox motor. Also, it goes out to each clock face, not to run the clock face, but for lights. Some of you may remember years ago those clock faces were illuminated from behind, and at night it showed up pretty well. I'd like to see them illuminated again. But at any rate, this was here, and I needed to get access to the motor, so I just appropriated the conduit and wiring that had originally fed the lamps behind each clock face, because the wires ended up the right place. The lamps had been removed. I don't know what went with them, but they were gone. And I just used existing conduit and wiring from the stepper motors. They're not a safety hazard or anything bad as this looks, because the stepper motors basically have 8-volt pulses going to them. Nothing that can shock anyone. I used to worry about, until they got the dome cleared out, I was working out there and had a lot of old cardboard and scrap wood and stuff like that. I worried, well, if any of my equipment had set the dome on fire. About it in history. But I thought, well, you know, only Earl Willoughby knows the name of the last guy that burned the courthouse, so maybe nobody will remember it forever. Well, at any rate, what I've added was inside this box that was already there. I had to put a little transformer in there to work my equipment. There's additional relay in here so that the microprocessor can actually energize the bell strike. Had to change out a couple of fuses, had a little problem with the fuses that went to the bell, and then there are fuses for the low voltage, and there's a cable that doesn't show up too well that goes into this box, which used to power an old personal computer, and this is just low voltage here, basically 12 volt AC. The microprocessor's up in this box. This is a little control box we put together. It's just 12 switches, and it doesn't show up too well here, but there's a switch for each clock face. And normally the clock face is set up there running, the motor's running clock faces, but you can de-energize a motor. If you want to stop a motor, you can just flip the switch and it stops that motor and then the others run. And that gives you a convenient mechanism for synchronizing all the clock faces. If they're out of sync with each other for some reason, the easiest way is just to set them ahead of the correct time. And if a clock face is 3 minutes ahead of the correct time, you just go up and kill that switch for 3 minutes and turn it back on. And then it's synced with the rest. There's a little connector here, and it feeds back around and ends up coming in and powering a relay. And every time it energizes that relay, it strikes the clock. You can also pull that cable out, and I've got another cable that will go into a laptop. And when you hook that cable to the laptop, plug it in up here, and do the right things with the switch panel, you can get some information out of the system. And you have to set the time of day, the day of the week, the year, the month, and etc., so that the microprocessor can keep the correct time. It's got the daylight saving changes programmed into it, supposedly with a calendar algorithm that stretches out for about 100 years and will keep track of the leap years. And let's see, is there anything else in there? That's pretty well it. This is the bell, for those of you who haven't been up in the dome. I saw in a newspaper write-up that this thing weighs 1,000 pounds, and if you see it, you can believe it. It's pretty massive. The electric solenoid strike mechanism, this is the IT burden equipment, swivels this, and I think this is brass or some material. It hits the bell, and that's what rings the bell. There was an old hammer, you can't really see it too well here, and I guess the old Seth Thomas mechanism could also strike the bell, and that thing looks like, well, it looks like a sledgehammer if you look at it. But some sort of clockwork mechanism was able to strike the bell back before the newer mechanism was put in. Well, of course, I wasn't going to replace this. It had a little problem with it a year or so back. It got overheated. It had some problem with lightning strikes during electric storms. It could kick the system off. Well, turns out if you turn that solenoid on there, which is actually the other side of the metal plate, it gets real hot real fast. It's designed just to get a power for a fraction of a second. And, up to 12 strikes, it's 12 o'clock. And it never gets hot because it doesn't have any power going through it for long enough. Well, if something happens that turns the power on continually, that ain't the case. It gets really hot. In fact, the heat's equivalent to about 10 100-watt bulbs. And so I changed the fusing on that. fuses that are in the area. If the power's applied for 2 seconds, they blow the fuses. Okay, with them. This is the vista up in the dome. I'm trying to remember, I want to say that's the west clock face there. And you're up about the north clock face looking across the dome. And there's all this old scaffolding up in there. I can just picture somebody perched up here, well, what, 25, 28 feet above the floor on the board, doing something under that dome. I think maybe at some time they tried to waterproof the dome from inside. Well, nobody'd send workers up on scaffolding like this anymore. I don't know when that date's from, but it needs to be cleared away. This is another shot. It didn't turn out terribly clear. I know there's a junction box with some of the wiring that went to the gearbox motor. And check on the screen.
Mention those insulators, John.
Yeah, I'll show you. Yeah, okay. These two little white things are the old style electrical insulators. If you work on the old houses that have got knob and post wiring, well, that's what this one is. And that, I'm sure, dates from the original Seth Thomas mechanism.
Looks like the old electric fence insulators too.
I don't know if they use up electric fence, but your houses had it back before they had Romex cable and stuff like that. You had individual wires for everything, and you run pairs of these all over the house to wire the house.
They look like the insulators from electric fences.
Well, could be.
Very similar.
Doesn't show up well at all, but in this area, the wood is pretty badly deteriorated. This got wet through the years, and it doesn't show up very well. There's a little hut up here with, I don't know what the material is on the siding, but that's all deteriorated. And the old Seth Thomas clockwork is in that little hut. The Seth Thomas, even though it was considerably older, there was a mechanism with an electric motor that rewound it. It was like a grandfather clock. It had big heavy weights that drove the mechanism. And I guess they had switches or something, so when the weight sank low enough, internal electric motor would wind the thing back up. I don't know whether the group that was looking at this back in 2007 did it or who did it, but pieces of the old Seth Thomas mechanism are lying about the dome. Like I said, it'd be a different project, but if you wanted to preserve that, clean it up, put it on display, first thing to do is collect all the parts. And I don't know, we've got an archaeologist or what's skill be required for that, but somebody knowledgeable about the tower clock mechanisms would have to look at that. That's just something at floor level. That's gone back around. Okay, let me see if there's any other thing I wanted to cover in here. I guess talk about some of the things I had to do over the months after I got the 4 o'clock faces going. We got all the 4 o'clock faces going March 31st of 2011, which was in time for the centennial and all. But there was some problems still. First problem was the power went off. The microprocessor didn't have any backup power, and it would lose time. It would come back on when the power came back on. It was just like any electric clock, it would be off. So you'd have to go reset the thing. Well, first thing to add was a battery backup. And so did that. It's got a battery I should have picked out and shown you. The microprocessor can operate the hands during the power outage, but it keeps track of the time. When the power comes back on, it goes to a higher speed mode and it runs the hands forward until you have the correct time. The bell control wasn't in the microprocessor immediately. That had to be added later. We used the original timer down in Danny Falk's office for the bell for a while and let the microprocessor just run the clock hands. But the bell will get out of sync with the hands. If the power went off, somebody would have to reset the bell down in Danny Falk's office. So by getting everything nested in the microprocessor, it could keep track of time. It knew when to strike the bell after the power failures. Had, like I said, problems during electrical storms. Several times the system was kicked out and go down after electrical storm, and it had stopped and restarted, and it didn't know what day of the year it was or anything like that, and you'd have to reset all that. Well, and finally we had an electrical storm, and it actually killed some of the circuitry. I figured that probably on occasion that dome would get struck by lightning and get a transient and it's hard on electronics. So went in and added a number of surge suppressors in the circuit to take care of that. And so far it seems to withstand storms. So hopefully we got that solved. Talk about future work. Like I said, I'd like to see some clearing done up in the dome. We got all this old wood, and it's real important. Back up. It's difficult to maneuver in there. I've got a ladder I brought when I started this and just left it up in the dome. It's tall enough to get up to the clock faces, but it's very difficult to maneuver a ladder up there. You've got all this scaffolding stuff in the way. It'd be a whole lot easier if that was taken out. And it's real important that the bell support be kept in good shape. Water has gotten on that on occasion, and if anything should happen to make that bell fall, you're talking about catastrophe, it could end up anywhere on the first floor of the courthouse, because there's a sort of a basement entrance or something, hatchway directly below it, wooden thing, probably go right through that. Once it's there, it's in the attic. That attic doesn't even have a solid floor. There's a walkway that extends over the upstairs hallway in the courthouse, and all there is on either side of that is suspended ceiling. And if you can postulate some sort of disaster that turns that bell loose, you do have a catastrophe. I would really like, and I've made a pitch a time or two, but didn't get somebody up there that's qualified structural engineer to look at what ought to be up there. But my feeling is that everything down to this level, which is just right above the beam that holds the bell, everything above that can be removed. And then something really waterproof put over this level so that if there's any drips through the dome, which there have been at times, it won't get the wood that holds that bell wet and won't cause any further deterioration of it. I'd like to see lights put back in the behind each clock face. Didn't think too much of it when I started this out. First place, if you have lights up there, well, you got to keep bulbs in the lights. But LEDs are so reliable now, if you get the right type of LED lamps, I think you can light those clock faces up and hardly ever have any need to go up there and replace a lamp. And it looked a lot better. If you go down there at night, they've got the courthouse itself illuminated, but the clock faces are dark. And it would look a lot better if they had lights behind them. As near as I can tell, there's no smoke detector in the dome. That's something that really ought to be up there. I even thought about adding a feature where the bell would ring, start ringing, and just not quit. It was fire. Wouldn't be too hard to do, but I think they probably have some sort of remote reading fire alarm system in the courthouse. Does anybody know? And there ought to be a smoke detector up there and hooked in, even though there's very little electrical left up there. There's a couple of outlets, and no fixed illumination though that I know of up there. I would like to, and one of these things that I'll get around to, I hope, is just to repackage the microprocessor system a little neater. The microprocessor itself is in a waterproof carbon box, you call it. You can get them out at Lowe's and used them in my work a lot over the years. Nice waterproof junction boxes. Then there are power transistors and some ballast resistors in this box. It gets not hot, but warm, and it's ventilated. I'd like to put this in a little bit better, more waterproof packaging, because water does get in here on occasion.
You may have mentioned that electrical storm affect system. What about humidity?
Okay, the neat thing about these little motors, they don't get very hot, but they're always warmer than ambient. And they're warm enough that, like the conditions we've had the last few days, are not going to cause moisture to condense on the motors.
Do they make those motors explosion proof?
Answer that. Basically, the motor itself cannot generate a spark. There are no brushes or anything. The stepper motor is actually a type of permanent magnet motor. It's got a special magnet arrangement in there with basically 50 teeth on it. And it actually takes 4 pulses that you produce by powering these wires in different combinations. Each time you go through that sequence of 4 pulses, you move 1 tooth. So it takes 200 pulses to make one complete circle. And so you have to get 1 RPM out of that shaft, you got to give it 200 pulses a minute. But there are no sparks. I would consider it explosion proof to an extent. I don't know what would explode up there. There's no fumes or anything.
Where, you might know this anyway, where there are gases that could explode.
Oh yeah, I'm very familiar with it. One of my jobs in Oak Ridge was to put some equipment.
They're also waterproof.
Well, of course, something can be waterproof without being explosion proof. Yeah, I did some work on a facility that electrolytic line that was producing heavy hydrogen out of heavy water, and heavy hydrogen is just about as explosive as regular hydrogen, and everything in there had to be explosion proof. So, but you don't have that type of hazard around for these. Plus, these are mounted about the driest place up there. They're up behind the glass, high up in there, and each glass window's got a little arch over it, and water basically can't easily get into the things. It wouldn't stand being immersed, I don't guess very well, although it would probably still operate for a while immersed.
And all your wires going to your motors operate synchronously.
Yeah, they're carrying little pulses, 8-volt pulses, basically, positive and negative pulses.
Just to each motor.
Each motor. Yeah. Well, there's another little trick that's done there to balance currents through the motors and all. But basically, yeah, at the same time, every time one motor gets a pulse, they all get a pulse.
Hey, John, two things I remember as a kid about that dome. One was the Christmas lights that appeared to come out of the very top and drape over the dome each Christmas. And the other was the fact that there used to be a flagpole on top of that dome. Can you speak to those things at all?
Yeah, I talked to Kerry down at the courthouse about that. He said he actually did something with that flagpole at one time. I don't know when the flagpole disappeared. I think it was after I moved away from here back in the 60s. If they wanted the flagpole back, you need some way to get to it, and you certainly wouldn't want to crawl up on the woodwork that's there. And there's been a sheet metal sort of a rain shield installed on top of all this wooden structure. I'm not even sure how you get to the flagpole. If they wanted to go back and have a flagpole, they need to design some sort of stairway, something to get up to the opening in the dome.
Is there an opening up there now?
I'm sure there's an opening in that. There originally was an opening, and it's poured concrete. I don't think they poured concrete in it to close it. It's got something closing it. I know that when they were having trouble with water getting in the dome a few years ago, if you went up there, you could see water lying on top of this metal,
Okay.
which was all sort of crumpled up as though something had hit it and crushed parts of it. Let's see if we've got some pictures of that. Oh, here's something I meant to mention. I don't know what's going on here. See how that doesn't line up? I think this is the only clock face on the dome that doesn't. Well, this is all concrete structure out here. I don't know whether that's the way it was cast somehow or whether there's been some shifting to it.
John, I think that probably actually limestone.
Well, no. The dome, of course, itself, the concrete. And it's got reinforcing wire in it. I know at the north face, if you go up there and look, some of the concrete's flaked off and you see this rusty wire up in there. It's not, I think somebody needs to come in and look at this dome, think about earthquakes, and think about fires, and think about all these things that the structural people are responsible for, and decide what ought to be done up there.
If it was limestone, would they not be white powder residue on there?
I really think it's all concrete, but I guess that would have been cast separately and put in place somehow. You wouldn't pour the dome and all that at the same time.
I'm thinking it was probably, cast by itself, and the limestone laid around and the dome poured around it.
Could be, I don't know. It'd be interesting to know. I might mention, I need to get back up there on the west face. The west clock face is not running right now. The gearbox on it gave me some trouble when I did the original work. The worm and the worm gear didn't line up well in there. And I tried to get the worm gear loose on the shaft and get it lined up, and it just didn't want to budge. And I couldn't beat on it with a hammer or do anything with it to move it. So I just left it the way it was. It ran pretty well over the past 8 years, but here lately, it's not. It's binding up. I tried changing the oil in it. That didn't cure the problem. So really the gearbox needs to come down. Get the gearbox down, have to put a ladder outside on the roof, go up and take off the hands and loosen it, remove the nut that holds the gearbox in the glass. And you have to get up inside the dome on the ladder, pull the gearbox out, and reverse the process, of course, when you put it back together. Incidentally, it did take a little precaution since they're having so much trouble with the roof up there leaking. I don't set the ladder directly on the roof. I've got a piece of plywood. It's got carpet on one side. And the carpet fits down against the roof, and there's a 2x4 on the other side to put the ladder against so the ladder doesn't slip. And makes it halfway safe to get up on the ladder.
I was a masonry contractor, whole entire working career, and I actually did a lot of repair work on Madison County Courthouse. And it's all limestone, only brick.
Oh yeah, it's a newer structure than this, of course.
It was built 30 something.
That's a nice looking structure. I sort of reviews then that Barbara and I came back in 2010 to Dyersburg. My grandfather came here in 1910, and his first drugstore was on the east side of the square. Wasn't there very long before we moved north side of the square. And of course he watched him put this courthouse up, and sort of take a little pride in working on the thing since my grandfather saw him go up in the first place. And I think of anything else. The last coating of the dome, incidentally, seemed to have helped a lot, because the thing just wasn't watertight at all, and for years it's leaked. And when we got to the point they had trash cans and buckets in the hallway in the courthouse to catch the leaks, of course they worked on it.
Being that old, it probably, the concrete probably wasn't vibrating in place.
Oh, I feel confident they have vibrators.
So it's probably forced because of that.
Yeah, and I know my co-op student, I worked at Alcoa, and Alcoa had dams up the mountain. A dam doesn't hold the water back. Water goes through a dam. It seeps through, but it goes through.
Steve?
Got a question about the workmanship on the original clock face.
Yes.
If all four of those, were they close enough in the exact same size, to be the same size, could they have ever been interchanged, or were they all just individually made?
I feel confident that they were all the same size. I don't know what sort of tolerance you'd have, but like I said, 33 inches across. This frame is a casting. I can't recall whether it's all one-piece casting or not, but the frame sort of dictates how big the glass can be to fit in it. And I'm sure they probably didn't have more than one setup for casting the framework.
If you decided to go back with LED lights behind it, would your repairs show, or are they fairly transparent?
It's possible they would. You just have to see. It'd be easy enough to go up there with just a portable LED light, light it up some night and see what it looks like.
With just a big spotlight.
Yeah.
Handheld spotlight. You shine it on one and somebody outside.
Well, I don't know how many lights around. You want it to look fairly uniform, I think.
Original lamps still there?
No, there was some really old lighting up in there. You can see some really old sockets on some of them. And then one of my pictures, I think, showed something that looked like fluorescent lights. Let's see if I can find it again. lighting in that one. Could have been a picture we didn't use. But at any rate, at some point in the past, sometime between probably 65, when was pretty well gone from here then, and when we came back, whatever lighting they had up there was taken out of service. I know some of the stuff lying around the dome and started working when it was old light fixtures. There were Christmas bulbs too. I mentioned the Christmas bulbs. My understanding is that they just threw ropes over the dome somehow and fished the Christmas bulbs up there. They didn't try to put them up through the hole the flagpole occupied. I don't think they did that way. I think they just hoisted them up there.
Did they have a big boom truck then, did they work outside?
I'm sure they didn't. I don't. We brought in a boom truck for that. If I recall Kerry right, they actually just got up there, I guess, with ladders and ropes and managed to get the lights in position. I think it's just something you go out and see what it took to do it.
What questions do you have?
Have you ever worked on anything like this before, or you just, something you
Oh,
just got into?
yeah.
Based on your
My-
background?
My background is I'm an electrical engineer. Like I said, my wife and I were in Texas 6 years. I worked for Texas Instruments for about 5, and a little electronic outfit called Ostrom for another year and a half, and went to Oak Ridge for 36 years. And I did computer work. I did a lot of industrial automation and instrumentation and control mainly. Did things with stepper motors, servo motors, all just a variety of things that they had around the plant. Stuff that's different is high frequency induction furnaces for casting uranium, rolling mill. We had a rolling mill had to do some work on. Spent 7 years on a project to build a centrifuge enrichment plant at Pikeman, Ohio. And after 7 years and $4 billion through government's work, they closed the project. And the most satisfying job I had in Oak Ridge was actually after I took a retirement. I actually took retirement in 2002 and went through a job shop outfit working on the spallation neutron source for 5 years as that project was building. And of course, at the end of construction, my contract ran out. On that project, we did a lot with programmable controllers, some special instrumentation that they needed for a project in a reactor, high flux isotope reactor. I don't know, there's such a variety of things you did over the years. A facility like that. There are actually 3 facilities in Oak Ridge, and different times I worked at all 3. And then there's a facility, like I said, at Pikeman, Ohio, and another one in Paducah, Kentucky. And had jobs up there. My wife.
Something that I thought was interesting, we were really excited the day that he was going to go and turn the clocks on. And we got down there and they could hit the clocks on, and everybody looked and said, but the bell didn't ring. And they didn't want him to do the bell because they said it made too much noise. And so then when the clocks worked, they would want the bell to ring. So we had to go back and...
Yeah, initially the microprocessor didn't run the bell because they didn't want the bell to ring. Or at least I was told that. But evidently it was.
There were a few other humorous times too. he locked himself out of the dome,
Yeah.
out on the,
Well, that's another maintenance item.
All right, you can go home now.
I was up there one cold winter day. This project, the initial part of it took about 4 months really. And through the cold months, January, February, March, and some days you couldn't work if they were just too cold or it was raining or something. But I was up there one day and the wind somehow slammed the door and you couldn't get it open yet. So I had to call my brother-in-law, I think, to get him to call the guards up there, or the bailiff up there to come up and let me back in the dome. Well, that problem doesn't exist anymore because the door's all sprung, it's tied together with a rope. So the door won't shut to start with. The door needs to be repaired on the dome, and there's other work that needs to be done up there. And it's one of these things, maybe it doesn't need to be done next week, but it needs to be done someday, or the deterioration will continue until we have some kind of a real problem.
I renamed the clocks, they were Mary, Martha, Betty, and Joan. He spent so much time with this.
Well, let's give John a big hand for the work he's done. Don't forget the ribbon cutting tomorrow at 11:30 in the archive. We still got snacks and coffee on, so y'all make yourself home for a while. There's another group going on down the hallway, but the museum is open. If you haven't seen it, you're welcome to go down and see that too. Thank y'all.